So thanks for joining. I'm Yasmin. I'm the head of customer success here at Mazebolt. So really excited to speak to you guys today about our AI journey.
Yeah, thank you all for joining us. Today we're introducing RADAR VectorAI, which is a new add-on module of the RADAR platform, and honestly, the most significant we had recently. So I'm really excited about it. Today, AI-powered attacks can already craft a never-before-seen DDoS attack vectors, but this is not like a future threat. This is what we're seeing today, in today's world, in today's attacks. So actually, it exposes the hard truth. So DDoS testing only relies on the known attacks, the known attack vectors, which means it misses this entirely because you cannot validate against this threat, and your protection can't test what's they never been designed to produce. Today, live, we will show you how RADAR VectorAI closes this gap. Feel free to drop any questions in the Q&A chat as we go. And if we will have time, we'll cover them as many as we can towards the end of the session. So let's jump in. Yasmin, the stage is yours.
Brilliant. Thank you, Yam. I'm just going to dive straight in. Okay, brilliant. Before we start talking about AI, I wanted to just give a little bit of a recap for those of you who might be new to Radar and what it is that we actually do, and then tie that into our new developments with Vector AI. Radar is actually our patented solution that allows you to test any DDoS attack vector non-disruptively in your production environment. And the importance of this being non-disruptive is that it breaks you away from the limitations of running red team tests, where you have a limited time window and you can only test a limited number of attacks and you have to schedule a maintenance window. So it actually allows you to test DDoS attacks outside of that. And the way that it works is it allows you to test all of the attacks at a very low rate that's low enough that it's not going to impact your network, hence the non-disruptive element, but it does trigger your defenses, so it allows us to test if your defenses would have actually triggered and stopped the attack. So this way you can test your entire attack surface whenever you want across all of our attack vectors, non-disruptively, continuously, multiple times a year. And that allows you to see all of your vulnerabilities through your whole attack surface, and then remediate against those vulnerabilities whenever you can and have time, and then retest whenever you want again without any limitations in terms of time or worrying about it disrupting your network operations. So what does this look like from a service perspective? We actually provide a fully managed service. And what that means is from the simulation stage all the way to the reporting and tracking and then re-simulating, we help you along the way. So we help you to first deploy the solution, to set up your simulations, to schedule them. We help you with deciding which ones to do first, with which frequency to do it with. We then help you to understand the results and prioritize the recommendations that we provide you. We then help you to discuss, even with your vendors, if you would like, which remediations to do first, how to do them. Then we also guide you along the way if there are any questions that you have in that remediation journey. And once you've confirmed that you've remediated something or the vendor has remediated something, we can actually validate those remediations by retesting only those attack vectors and then seeing if they've truly now being protected in your environment. And then along the way, these are all being reported and logged in the system. And then you can also generate point in time reports in the system. And obviously, we can also generate graphics that show you the improvements that you've made over time in your security posture with respect to these DDoS simulations. And now moving on to what is new. Like Yam said, the actual gap was that now we're seeing that out there with AI now being used more and more with attacks, we're seeing that there's novel attacks. There's now DDoS attack types that we haven't seen before. This is very worrying for customers. So you will see that your protection vendors are also introducing new AI protections to try and protect against these never seen before attacks. However, there's no way of validating that any of these AI protections are actually working. So what we wanted to do with Vector AI is produce a module that essentially takes certain information and generates never before tested attack vectors so that we can then test against those and see if your AI protections are actually working or not. And the way that it works is quite simple. So it takes all of the known attack vectors and then all of the configuration options and permutations that those attack vectors typically use, and then it mixes them all up to try and see if there's something there that's never before been tested that would actually be damaging and work. And then it tests any newly found permutations against any environment specific inputs that we have about our customer, including the types of protections that they already have in place, and makes sure that this new discovered attack method is something that has never actually been seen by these prevention methods and wouldn't be protected in any way that we can see or know about. Using all of that testing, it generates this new attack vector that can then be used in the simulations that we have with radar alongside our attack vectors in the library that we have. So this is what Vector AI is doing. And here is a different way of sort of visualizing that. So it's taking all of those attack vectors and then it's messing with the permutations that it can use. So it's mixing something that maybe one attack type uses that the other has never tried before and finding that novel mix. And then it's testing that against the known protections and the environment that we know of our customers and seeing which ones of those new novel attack vectors will actually penetrate and get through. And that's the one that is generated. The whole idea is to generate something that's really unique that then can be tested. And that allows you to actually validate whether all of these AI defenses that you're putting in place with your DDoS protection vendors are doing what they are stating to do, just as Radar does with everything that's not AI and before we released Vector AI. With that, I will actually hand over to Yam to talk to you a little bit more about the mechanics of how Vector AI actually works on the product side.
Thank you, Yasmin. So what actually happens once the user clicks generate? So first of all, the AI pulls data-driven insights, millions of real DDoS attack data, points from Radar's own history. So the AI is starting from real evidence of where your specific vulnerabilities are most likely to be. Then that data feeds into the LLM module, where it is created and customizing the attack. The LLM will be selected based on the customer's choice, and where you can select it on the attack generator page on Radar. Then it's converting the LLM response into something that can actually generate and execute traffic, so it can actually see that as traffic. Then it's starting some sort of internal QA. Once you see this little green check, it means that the attack vector is ready and can be used in simulation. Basically, all of the attacks that the user is generating has been informed by real data designed by the leading LLM models and safely checked, even just before it gets to your environment. Let me dig into the platform so we can actually show you how it looks like live. This is Radar. Now we're in. We'll be showing you here in the demo in Radar what is Vector AI, where you can generate an attack, where you can view the vectors that you have generated, and how to actually use them in a real simulation. So here on the left menu, you can see the new Vector AI tab, which includes two different new pages. The first one is the attack generator, and the second one is the attack library. Let's start with the attack generator, because this is where it all starts. So as a user, I want to tell Vector AI how to collect its data from and how to actually make the attack customized to my needs. So as a user, you need to fill 3 fields here. The first one is profile, then port, and lastly, attack layer. Profile, the profile field is basically the deployed security layer that the user has on his environment. This gives the attack the context of the defense. The port is basically the target port number. So for this example, I want to use port 80. So it means that for this example, my target is an HTTP type of target. Lastly is the attack layer, which is the OSI layer that the attack vector is targeting. And just before I click generate, I want to make sure that the AI model that I'm using is the one that I actually want to use. For this example, we will be using Claude Sonnet 4.6. And after I configure that, I just click generate. And that's it. Vector AI is starting to generate an attack. It walks you through the steps, where it's currently loading, what it's doing, which is what I showed earlier. It can take up to 5 minutes. So while it's loading, Yasmin, I'm bringing the stage back to you. And then once it will be generated, we can get back to it and continue.
Brilliant. Now we wanted to take you a little bit on the AI journey that we've gone through. When we talk about AI, we're usually talking about some kind of machine learning, and that machine learning needs to be based on a rich and large data set. So where does that data set actually come from, and how have we evolved to use it over time? So that data set for Mazebolt actually means the combination of different attack vectors against different targets and each one of those simulation results. If you think of one simulation cycle that we've ran, we will run a bunch of our 150 attack vectors in the library against a number of targets in a specific company. And that alone generates a number of permutations of different actually single attacks. And each one of those will either be successful or not successful. And that gives us a rich data set even on its own. And this is quite a simplified version because usually it will be every attack vector against every target in that simulation cycle. That gives us already quite a rich view of which one of these attack vectors are successful and on which targets. And then if you think about multiplying that across hundreds and thousands of different simulation cycles that we have in our data set, we then get an extremely rich picture of which attack vectors are more successful and on which type of targets and in which scenarios. And we can analyze all of that data to see if there are specific patterns that we can draw out that might be useful. And this is how we started thinking about how we can use AI. And what we discovered in that journey is that actually by knowing these 6 things about any specific target or environment, you can actually predict with quite a high level of accuracy what they're most likely to be vulnerable to. And that's quite powerful for many different reasons. The first thing that we actually used it for is to talk to prospects who are interested in deploying Mazebolt, but don't want to actually, take that step first. They can actually see the nature of the problem and how big the problem is just through this prediction model. So it's quite useful from that perspective. But actually, then we wanted to use it for our customers as well. What we decided to do was use this prediction model from AI to take these 3 top attack vectors that they're most likely to be vulnerable to, and even the top 10 in some cases, and actually use that to make the cycle more efficient. If you think about it, and you will see with YAM later, when customers are scheduling simulations, usually they're scheduling a start time and an end time. And sometimes that's based on a specific maintenance window just because they feel more comfortable doing it that way or the security policy requires it. And sometimes it can be for a whole day because they want to run it continuously and they don't mind so much. But if that is limited, and if you think about the number of simulations that you're trying to run, so if you're trying to run 150 attack vectors against, let's say, 100 different targets, that's already 15,000 different simulations. So that can take a long time sometimes to finish that kind of attack, and it might not always finish if you've set a very small window. So what Smart Cycle allows us to do is use that predictive model to test the vectors that are most likely to be vulnerable first to get the most meaningful results out of that simulation cycle. This is something that runs in the background of the product, not something that's necessarily visible to the customer, that's always on and running. So this is how we used AI initially, and it's almost a very initial step towards using AI to orchestrate the simulation in a more efficient way. That leads us into the story of orchestration versus what we're talking about now with vector AI, which is AI generation. Now, this was a very important step for us because if you're seeing what's happening in the market now, AI is now being used to generate very novel ways of attacking that actually haven't been seen before. And this is what is creating a lot of frenzy. It's also what's meaning that there are now a lot more vulnerabilities out there and there needs to be a lot more frequent patching. And this is really the latest change that we've seen out there in the industry and why we wanted to build really an AI generation tool. The aim of this tool is to generate something that really hasn't been tested before, that would really be a new way of running a DDoS attack, which is very different to orchestrating existing attacks in a more efficient and effective way. So if we dive a little bit more into the difference and what these actually mean, AI orchestration is really looking at different components of an attack. So for example, switching vectors or switching targets or changing the allocation of your botnet geographically or the number of nodes that are in your botnet. changing the timing and pacing of the attack. Some attacks are continuous, some ramp up, some stop and then start again. So every attack type has a different way of working. The AI orchestration is really seeing which ones of those, which different components are more effective on a specific target. It's learning from that, and then it's suggesting to you, how will I then improve my next attack to make it more effective? And it keeps on doing that. It keeps on going through that cycle until its attacks are extremely effective at hitting the target. So that's orchestration. Now, when we move over to generation, this is actually something a lot more creative. It's taking all of the possible permutations. It's not taking what exists and what's been run before. It's saying, let's take all of the different types of attacks that have existed. Let's take all of the different combinations of components and ways of configuring those attacks that are possible. And let's mix all of those permutations to find something that's perhaps never been tried before, but can still be very damaging. And then let's take that never tried before combination of attack and test it against existing defenses and see if those defenses are actually able to protect against these attacks or recognize it in any way. And if none of those defenses recognize this new way of attack that hasn't been seen before, then you've actually generated a novel way of doing a DDoS attack. And that is what really Vector AI is generating and then allowing you to test your defenses against. So now I want to hand over to Yam again to look at the results of our generated Vector AI.
We can see that still happening, being generated. Again, it's under the testing part, so it's doing the QA, the internal QA now. So in the meantime, while it's still loading, we can review the history and the buttons. So clicking the history page, you can see all of the attempts, both successful and unsuccessful attempts to generate an attack. And the new button, basically currently it's unavailable because the attack is still loading. But once it's finished loading, and you can just click it and it resends it to the first page, which I showed earlier, where you can actually start and generate a new attack. While we're giving it a few minutes, oh, there we go. This is now telling us that it successfully generated a new attack vector. We can see the name of the attack. So for this case, it's an HTTP type of attack. This is a layer 7, which is the OSI layer we selected, the port number that we entered, and a short description about the attack itself. So now let's dig into the attack library and what is it. So until now we had 150 attack vectors, which we call it the known attack library. Vector AI is creating a whole new library which documents all of the successful generation and attempts of the attack vector. So every attempt that has been successfully generated automatically being added to this attack library. So here you can view all of the attacks that we previously generated. You can see the generated time when it was generated at. You can see the name of the attack, the layer, the OSI layer, and the short description of the attack. The user can also search by the name of the attack if he wants to find a specific one, or to filter by the OSI layer that he wants to see. I would mention that this attack library over time becomes, as long as you create more attacks, it becomes some sort of archive that you can keep all of the attack vectors that no one has, and it's only tailored to your environment and customized for you. Here you can again see them all. Now, how we can actually generate a new simulation cycle using these new attack vectors. So like the usual radar flow, we go to simulation and to the scheduler page to schedule a new event. So you can see here a calendar. Currently it has no events running, and we want to create a new event. So I'm clicking this button, and for this example, let's call it weekly Mondays. It means that every Monday I want the system to run a cycle. We want to stick with the standard assessment because this is the first time we're running the cycle. We can also add a description to make it more personalized and understandable for us later. Then we're clicking next. Under the profile section, we can select which profile we want to use for the simulation. For this example, I'm using the scrubbing profile. Under targets, I want to select a specific target, and I want to use Vector AI as an example for the target. Now, under the attack vectors, you have a few options You can either select the coverage groups, and then you can select which group you want to run. You have the baseline plus, and insight, which is the known, which all of them includes the known attack vectors. You can go, you can select categories, and then select which category you want to run, and hold sign there. You can go by statuses and then select which status you want to use, protected, partially, or vulnerable. And then lastly, specific attack vectors. So under this tab, you can actually select which attack vectors you want to run one by one. So currently you have the 150 selected attack vectors. Now, for this test, we want to include all of the AI-generated attack vectors with RADAR VectorAI. So I'm clicking that, and then automatically we see that the system selected 8 attack vectors for this cycle. Then I'm clicking next. So under time and duration, you can actually select when you want the cycle to start and when you want it to end. So for this example, I want it to start next Monday because this is what we call the event, and I want it to start at 2 p.m. Then I want it to end on the same day, and I want it to end 2 hours later. So let's do 4 p.m. Now, since it's a weekly, then I'm clicking weekly, and I can select when I want this cycle to end. So I can either select on a specific date, or I can select after a number of occurrences. So for this example, let's add 5, and then I click create. Now the system is creating a cycle, and you can see here on the calendar that every Monday we have an event, and it's happening only 5 times as we defined. At any stage, you can go back and edit your cycle, edit your event, change it, switch the target, the attack vectors, as long as the simulation will start. And that's it, as simple as that. So I think we still have time for questions. So let's see what questions we have so far. So I see here one question. I'll read it out loud. If I have a customer generate a new attack vector using AI, will other Facebook customers be able to see it and use it? Yasmin, I think that's a question that you can answer.
Yeah, I'm happy to address that one. This is actually a very important question because we talked about vector AI using customized information about a customer's environment to generate that new attack vector. So actually, that AI attack vector library is specific to the customer that generates it. It's not visible to any other customer and cannot be used or shared with other customers as well. It is personalized specifically to you and not shared with others. So you can rest assured from that perspective. And it's also not automatically added, therefore, to our standard attack library that has 150 attack vectors in it. So that's only you as a customer can add the ones that you've generated to your simulations.
Thank you, Yasmin. Let's see, we have another question. I'll read it. For organizations that have already deployed AI DDoS protections, would they need vector AI? So I think that's a great question, and I can answer that. So having AI protection and proving that this AI protection works are two different things. And having AI in your DDoS protection doesn't mean it's working properly and configured properly. It needs to be configured, it needs to be kept up to date, just like any other security tool. Vector AI's job is to test exactly that. So we create a brand new attacks that your system have never seen before, and these vectors have never been existed before. And we actually throw them at your defenses to see what actually happens, whether they were able to block them or did they miss them. So try to think of it in this way. So your vendor, their AI in their own lab, and we're testing it in your real environment against your real parameters. So that's the only way to actually know if it's working instead of just hoping it does. Don't think we have any more time for questions because I don't want to exceed the time that we have defined for the session. But please, if you have any more questions, if you want to reach out to us, please feel free to reach us directly, either myself or Yasmin on LinkedIn. You can also reach out to us on the website. Every question, concern you have. And thank you all so much for joining us and listening to us. and we will see you on our next webinar. So thank you, everybody.
Thank you, everyone. Bye-bye.